it's 1:30, so I think it's time to start again. I hope you all had a nice lunch. It tasted good and you're now ready for the afternoon. Do we have any open questions? Anything that you discussed during lunch where you would like to, I don't know, discuss it with everybody in this group, or did I describe something not well enough so you have some open questions, anything like that? Good. We have to finish the gRPC sample. I told you that we will spend approximately a quarter of an hour finishing our gRPC sample, and then we will switch gears and move towards SignalR. So let's continue. Let's pick up where we left. Just to refresh your mind, we created a proto file where we had a duplex streaming. Client streaming requests to the server, server streaming results back to the client. The second thing, just one example, we consume the proto file from a different source. In our case, it's from Google. Good. So we added the proto file. Now we can enhance the Math Guru service here on the right-hand side. And again, just like before, we will not type this solution. It would take way too long. We will copy the solution from my GitHub repository. You can find the necessary code here in this folder, gRPC server services Math Guru service. And there we have this get Fibonacci step-by-step method. This one is what we are going to copy. It's a little bit longer, but I will walk you through the entire implementation. Yes, here we are. Looks good. Maybe let's do it this way. Good. I show you again where you can copy it from. If you want to follow along, beyond REST, gRPC server services Math Guru service. And there you find the get Fibonacci step by step. But the first thing that we are going to take a look at is, I think I can keep it like that. I hope you can read it from the back. Let's take a look at the method signature. Two important things I would like you to recognize. First, the request is now not just a parameter that comes in as a class, but this time we get a reader with from two parameters. So we get the request streaming in from the client. And we have to read the requests. On the other hand, the writer is our response. We can stream the results back to the client. Now the important thing is that we, as the gRPC server, are in control of the speed of pulling the requests in. The client can send us a lot of messages, but at the end of the day, we define the speed with which we work on these requests, and then we send something back. It can be a back and forth. Now let's take a look at the implementation. Because we have a request stream, we are now on the server, we can again make use of this great feature of C#8, which is the await for each. Await for each says, here, wait until we receive a request from the client. Await does not block. It's a non-blocking operation. It frees all threads. The server can do whatever the server has to do in the meantime. And once a request comes in from the client, we get woken up and our code starts exactly there. That's the idea of await for each. It's not wait. Please read await, not wait. That's a very important thing here. Okay, we read the requests. Now, an interesting thing is, well, the first one is really simple, item from to, but the interesting thing is how we deal with errors here. You see, in this case, we are returning a step-by-step result, which includes a status class, which was generated from the proto file that we imported from Google. You understand what I mean? And this one, invalid argument, is from the code enumeration, and the code enumeration was again imported from a protofile from Google. So here you see a nice language integration where we just imported protofiles from a third party, in our case Google, in your case maybe an important protofile that you got from your colleagues in a different microservices, for instance. Now let me quickly open the protofile again. Can you remember here, one-off, numeric result, or status. So if we check the method overloads of this writeAsync method, then we can say, in this case, let me show it like that, response stream.writeAsync, and here well, I'm sorry, I did something wrong. Not here. It's in the step-by-step result. I'm sorry. Here in the step-by-step result, we have two different properties. We have one property, which is the numeric result, and we have a different property, which is the status. So we can decide which property we set. So by deciding that we return the error here, and later on, result here, we decide which part of the proto is set. This is the one-off. Get the idea? Good. So let's continue to take a look at the code. Yeah, we just check whether item from to does make sense. Okay, let's forget about that. The next one is more interesting again, because in this case, I would like to draw your interest to that one, this one. Now this is handling state in gRPC. Because what I do is I remember each request, the previous request, and when a new request comes in, I check whether the new request is higher than the previous request to be able to decline requests that don't make sense. You get the idea? So in this case, I'm really storing here, I'm storing state on the gRPC server that I can use throughout the streaming of the results. Let me finish my thought, okay? Now this one is important. This works perfectly well inside of one connection. But if the connection breaks, of course, I have to find a strategy of starting again. This is something that gRPC does not handle for you. So if something breaks and the status gets lost, you have to find an algorithmic way of getting started again. Okay? This is the reason why gRPC, especially the bidirectional streaming, works very well in situations where you have a microservice-to-microservice communication over a rather reliable network. It doesn't make sense over a poor network with, I don't know, 4G mobile phone stuff. It doesn't make sense. Then you are more busy reconnecting and setting the bidirectional communication up again. It doesn't make very much sense. You wanted to clear? Good. 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 So we can check what we did previous. Yes, question.
Is it actually guaranteed that it comes in the order the client sent the request?
Definitely, yes. Yeah, that's definitely guaranteed because it is sent via HTTP 2. There is no buffering in the middle or something like this. Yeah. Okay, so then we do some calculation logic, nothing special here, and send the result back. Okay? So pretty clear. The only specialty is that we need again some feature in order to process the incoming stream, and a wait for each is somehow handy here. Good. Nice. So this is the server part. Let me quickly try to compile this to see whether it works nicely. Good, build succeeded. Okay, we can switch to the client. Question?
Can the client already send the next request when the first request hasn't finished yet?
Absolutely, and you will see that in a second when we come to the client. Because the client in this case is more complicated than the server. So let's go to the client here, go to my program CS, and again, let's copy some code. This time we will go to the gRPC client, go to program CS, and move down, and now we want this bidirectional streaming method. I will copy the entire method. This one. This is what you need to have. From the Beyond REST gRPC client program CS, the method bidirectional streaming. Good. Let's go to the client here and add, what's that one? Yeah, here it is. Good. Let's add this method, bidirectional streaming, and let's call it bidirectional streaming once the math client. Good. Now let's check the implementation of our bidirectional streaming. We call the get Fibonacci step by step, and please note that this method does not get any parameters. But it needs to have requests, right? Of course, but we need to stream the requests through the return parameter. So please note that here we get back an object that we can use later on to send requests to the server. You get the idea? We don't pass in the parameter here when we call the method, but we stream the requests to the server. And yeah, that's pretty simple. Write async, write async, write async, nothing special. But now comes the tricky part. The receiving and sending can work asynchronously at the same time. They are somehow intertwined. So we need to process the results in a separate thread. Get the idea? So what I do is I run a separate thread. You see that here. I'm using task.run. For the non-C# experts here in the room, a task is just a pre-created thread on a so-called thread pool. So we are not creating threads, we are using existing threads in order to save resources, that's all. But you can think, okay, background thread. This background thread now uses again the await for each. Now this is consuming the results. Get the idea? This is the result thread. So in our case, it will work like this. You will not be able to read the text anymore on the video beamer, but that's fine. I just want you to show how the program flow works. The program flow starts at the beginning, and here, where the task.run starts, we are starting a background thread, so the program immediately continues here. And here in this area, we have a separate thread, which is immediately here blocked. Not waiting, it's awaiting. So we don't have blocked I/O and blocked threads. We don't have that, okay? Because it's await. Now we are sending a request. This sending of the request will go to the server. And at one point in time, the server will send me a response which will trigger my background process in order to handle the response. Get the idea? And now comes the interesting stuff. While we are handling the response, we can immediately here send the next request. So request sending and response receiving is really happening intertwined at the same time. You know what I mean? It can happen that we are still processing the response, but again sending on a different thread a request to the server again. And the server will pick up this request as soon as he can. Get the idea? Okay, good. So let's check how this is done. Well, await for each, nothing special. And now this one, the switch one, this is the result of our one-off. The one-off gives us an enumeration payload case where we can check whether the server sent us an error or the server has sent us a result. Get the idea? One-off. So it can only be one of these two things. If it's an error, I'm printing something on standard error. If it's a result, well, I'm printing something on standard out, and that's it. We have to somehow find a way that server and client, that these two systems decide, okay, we can stop. We are done. Somehow, the client needs to indicate to the server, I don't want any more responses. I will not send you requests anymore. Get the idea? Otherwise, we would have an open connection forever. Somebody has to stop it. Let's not assume that the server wants to stop it. Of course, the server can stop it. The server can say exception, the server can send the status back, the server can just terminate the method. Yes, but that's the exceptional case. The typical case is that the client, please remember, the client calls complete on the request stream. So the client sends a complete message to the server, and the server says, okay, I will not get anything. And the beauty here is, if we take a look at the service, this complete call will automatically move us out of the for each loop. It will recognize when we read from the request stream that we got a complete message, and it will terminate the loop. So we don't need any special handling here. We just wait until the client sends us a complete message, and then we exit the for each loop just as it were a list of something. Get the idea? That's the programming model here that Microsoft has chosen. That is language specific. That will look different in your programming language of choice. But the general principle of streaming and so on, that's gRPC pure. Got it? Good. So let's get back to program. Yeah, and that's it. And if something else than error or result comes, we throw and yeah, that will not work. Good. Please note, before we run this application, that I'm doing a mistake here between 1 and 10. And then I'm sending a request between 5 and 15. But 5 is lower than 10, so the second request is an error. So we should get back at least one error. And then we have 20 to 40, and that's fine again. Good? Good. Now let's give it a try. And we have an error. Where do I have an error? Oh, I copied one angle bracket too much. That is easy to correct. Now build succeeded, and let's see. Server, client, let's zoom in a little bit to the client. And nope, something was broken. I messed up something. Let me see what I messed up here. Bidirectional streaming. Oh, I forgot an await. I'm very sorry. In C#, that's specific for C#. In C#, if the main method completes, all background threads are terminated automatically. That's different from Node.js, for instance. In Node.js, it's different. But I forgot this await here, and therefore the main method terminated, and then the server recognized that there is no client anymore and threw an exception that we could handle. That's all. Let's start again. I'm sorry for forgetting the await. Now, crossing fingers. Much better. That's exactly what I wanted to see. You see, 1, 2, 3, 4, 5, 8, that's the first request. Then we sent an invalid request, which led to an error. This is the one-off stuff. And then our third request is OK. So in this case, we are signaling back an error situation, which does not terminate the communication between client and server. The error it just indicates that the last request was an error. But the server is still fine with receiving additional requests, which are OK. Get the idea? So this now is bidirectional streaming between microservices over gRPC and protobuf. Good. Now we have completed our example. If you didn't follow along, maybe because you don't have Visual Studio or you don't want to type so much, you have in my GitHub repository the entire solution here ready implemented. So you don't need to go through this example step by step. You can just clone the repo, go in there, and you're fine. Okay? And then you can take a look at the code, you can run it, and you can try it. Good. I hope this example helped you understand a little bit better how the workflow with gRPC is and where the sweet spot of gRPC is compared to RESTful web APIs. Any questions regarding gRPC and protobuf before we move on to SignalR?
I have a question.
Yes.
Back in the client program, where you complete async, is there a reason why you await that? Because it seems like...
Which one?
So if you go to the client... Yeah,
this one?
Yeah, that one. Is there a reason why you await that?
That's a good question. That's a very good question. Thank you for that. Yes, there is a way. There is a reason. If complete async, for whatever reason, recognizes an error, it will give back a task with an error. And the place, if I would put the await, I will put it other way. In other words, if I remove the await here and an exception happens during complete async, I would never see this exception. If you do not await the task, any exception happening during the task execution is swallowed. It's gone away. You will never see it. So whenever you receive a task in C#, you should always await it if you want to see the exception. Only in the very rare case that you are really, really, really not interested in any exception happening here, then you can forget about the await. But I want to see any exception that might happen with this complete async, and that is the reason why I put an await here.
I see. Won't the exception bubble up to the call to bidirectional streaming?
Absolutely, it would bubble up, and I would see it in my console with the stack trace and everything. And that is exactly what I want.
Right.
Yeah.
And without this await, like if you remove this await,
if we
the exception go to
no.
It won't?
No, you would not even see an unhandled exception. You would see it nowhere at all. It would not be an unhandled exception. That's the important one.
I see.
If you don't await it. That's a common mistake when I help teams overcome some errors. In many cases, they just forgot an await. They never see an exception because it simply never bubbles up. It is never an unhandled exception. It happens somewhere deep down in the system, and if you don't know how to look into the logs and things like that, you will never find it.
I see.
Okay?
Cool.
I hope this answers your question.
Thank you.
Good. This is very C# specific. So those of you who don't write C#, just forget about it. Any other questions? Nice. So, take a deep breath. We are starting something completely new. We are now going to talk about SignalR. If you would like to follow along my sample, I have a starter code to which we will add some code later on, step by step. If you take a look in my GitHub repository, you will find this starter code here in this directory. This is the directory. And I created a zip file for you. You can download this one. You will need Node.js in order to execute it. No Visual Studio, nothing. You just need a rather new version of Node. I think the LTS should be enough, but I would recommend the newest one. So if you want to follow along, I don't want to write so much TypeScript together with you, so I prepared. We will only add the SignalR related stuff to this client. Good. Before we go into the code, let's quickly discuss what SignalR is. And let's do the exercise that we did in the morning, but now with SignalR. Imagine intern in your company, you're having a coffee with the intern, and the intern asked you, hey, I heard you're using SignalR. What's that? I've never heard that. What would you answer? Me too. I have no idea. Does anybody have an idea? It has something to do with WebSockets, right? You have maybe heard.
On WebSockets like Socketio, for example, for JavaScript, but it's
okay.
It's much bigger because it's based on WebSockets, but not only the WebSockets, because it has only or something like that. For old browsers, for example, it uses
I like that.
HTTP requests.
Yeah. Everything you said is correctly. Let me quickly take one or two pieces out of what you just said. SignalR sits on top of WebSocket, but not only on WebSocket. That's perfectly right. The first feature that SignalR gives you is protocol negotiation. It tries to use WebSockets, and to be very honest with you, I really encourage you to try to use WebSockets in combination with SignalR. But in the rare situation that WebSockets is not available because of some network restrictions, SignalR will fall back to long polling or server-side events. That happens automatically without you doing anything. Can you configure this protocol negotiation? Yes, you can, but we will not talk about the details. So, put that aside. We are today talking about SignalR as a thing on top of WebSockets. You said it's a library. And this is the only point where I don't fully agree, because SignalR is not a library. SignalR is a protocol. What can WebSocket do? I think let me quickly show you something. I have to look for a link that I don't know by heart. Where is it? Here is WebSockets. So, where is it? Yeah, something like this. So this is just plain, very simple WebSockets. Here it is. So let's load it again and let's take a look at the network. Looks good. Now, this is, you can try that on your own. It's a very, very simple demo app that is just sending WebSocket message without SignalR. That has nothing to do with SignalR. That's WebSocket pure. So if I go to WebSocket and hit connect, let's see what's going on behind the scenes. Behind the scenes, the browser, in this case, and the server are negotiating a protocol change. Just to recap what WebSocket really is. WebSocket is initiated via HTTP. And as you can see here, the client sends something with this protocol and the server responds to, okay, I am fine, I understand, you want to talk with me via WebSocket. I trust you, that's fine, let's do that. So it answers with a 101 response and says, fine, let's go for WebSockets. And from that point on, there is a standing connection between my client and the server. There is an open TCP/IP connection, which both sides can use to send messages. Client can send to server, server can send to client. This is what WebSocket is all about. This is built into any modern browser. This is built into nearly every programming language that I know. It works in Java, it works in C#, it works in Go, it works in Node, it works everywhere. So if we send something, send text, then we send something and we can even visualize this stuff. If we go here, you see, in Chrome, messages, and you see, here we see our messages flying around. We send something in, we send something out. And this screenshot is already showing you the problem with WebSockets. The only thing that WebSockets can really send is string or binary. And that's it. I can send messages that contains bytes, string or binary. That's not a very powerful programming model if you want to build a decent, complex application. Typically, you need much more. You have different types of messages. These messages have parameter. You need to serialize these parameters. On the other side, you need to deserialize the parameters. You need to somehow call a method either on the client or on the server. Maybe you want to put the clients, the connections into groups so you can broadcast to many clients. All these things are not supported by WebSockets. They are simply not there. And this is exactly where the SignalR protocol comes in. The SignalR protocol has been designed by Microsoft, but it is open source. It is maintained on GitHub. It is not just a library. It is an open protocol. Everybody can speak the SignalR protocol independent of whether it's Microsoft or not. Microsoft has created, and this is, I know what you meant and you're perfectly right, Microsoft has created libraries on top of the SignalR protocol. They implemented a JavaScript client I'm quite familiar with, a C# client I'm quite familiar with, and I think also a Java client. There are some open source Go implementations too, but we will not take a look into that. That's not an official client from Microsoft. But if you would like to write a client for, I don't know, Ruby, Erlang, Haskell, or whatever, you can, because the protocol is open on GitHub and it's not some proprietary stuff. That's an important one, okay? So what can you take away with that? It sits on top of WebSockets, exactly, and adds support for message types, parameter handling, and grouping of connections to do broadcasting. Good? That's essentially WebSockets. Sorry, SignalR. In our case, we are going to implement a small sample that should show us how this stuff really works. And let me quickly show you what this sample is all about. Here I have the starter code, okay. If you are new to Node.js and web programming and so on, if you download the starter code, as I said, you just need Node.js. For those of you who say Node.js, what's that? Node.js.org, download one of these versions, the long-term support version or this one, I would recommend this one, but I think the app should work with the long-term support too. It installs Node.js on your app. It's just a console app, that's all. It's really fast and not a problem. If you downloaded the code, you have to quickly execute one command inside of this folder, and this command is npm install. This is what you have to do. npm install. npm only runs if you have installed Node. If you haven't installed Node, you cannot run this npm install. It will download some packages from the internet and put them into the Node modules folder. Let me quickly zoom in a little bit here. So what it does, it fills your Node modules folder. Whatever that is, if you're not interested into Node and web programming, forget about it. Just remember npm install. Now what does this application do? Let me quickly show it to you, and then I will quickly lead you through the code in order so that we can work together. npm start, this is how you start the application. It gives you a development web server running on localhost 8081. See it here. You can open in your browser localhost 8081, and it will give you a black rectangle. Wow! But you can draw in this black rectangle. Take your mouse and draw in this rectangle. And our goal is that we can open many browser windows all pointing to this localhost 8081. And then if you draw in one area, in the other area we should magically see it. So we have a kind of shared whiteboard. This is what we would like to build, and we would like to assign everybody a separate color and things like that. Again, if it was too fast, npm install and then npm start. Did you download the starter code? And what is your problem?
Like it's SSL protocol errors for the local nodes.
You must not use HTTPS, you must use HTTP. The application is not configured for encrypted traffic. Does it work?
Connection refused.
And it still runs.
I think I downloaded it, but it's running at 8080 for me.
For 8080, maybe that's, but to try 80, you have to look at what it says here. You have to look it up in your console.
Got it.
Does it work now?
Yeah.
Yes, good. So let me quickly walk you through the code just so that you have an idea. The whole application, it's a client app, it's running on the client, and it works with TypeScript. So TypeScript is a typed version of JavaScript, and it looks like this. We have an index.html, which contains a canvas, which is just an area where we can draw. And then it contains a few lines of TypeScript code. The drawing code is in canvas.ts. It's really simple, and it's not production-ready code, so please don't tell anybody this is how Rainer Stropek writes production code for TypeScript. No, that's just for demo purposes. It's really simple. I get a 2D drawing context for the canvas, and then I react on mouse down, mouse up, and mouse move. That's all. Yeah? And when I move the mouse while the mouse is down, I'm drawing lines from the previous point to the current point. That's it. Really simple. Just 50 lines of code and it's done. Good? The project itself is written with multiple packages in mind. It uses, as I said, TypeScript to compile TypeScript into JavaScript. It uses Webpack for packaging up all the TypeScript and CSS and HTML and so on. And it uses, as a dev server, the Webpack dev server. That means it's a development web server that you can use locally. It's very convenient. It does auto-reloading. When you change code, save it. It's automatically rebuilding everything, starting the browser. It's really nice. Nothing special, okay? Yeah, you can take a look at the config, but it doesn't make any difference. Debugging is supported. If you would like to debug this stuff, press F12, go to sources, and I configured it so that you get debug support here in this area. So if you go in sources Webpack, dot source. Here you see the TypeScript code. So if you would like, you could, for instance, open canvas.ts. You will see the TypeScript code, and then I can, for instance, set a breakpoint here in the mouse up. And if I click and up, then it will break here. We will use that later on to debug this application when we receive WebSocket messages. Okay? So this is why I described that to you. That's also Webpack magic happening behind the scenes, doing all the TypeScript to JavaScript debugging, map file generation and all this stuff. If you're not that into web programming, forget what I said now, it just works. Yeah. Good. Happy with that. So everybody who wants to follow along should now have this application running. If nobody says, I have a problem, I will continue. You have a problem?
Several browser windows doesn't sync.
No, they don't. This is the code that we are going to write now. Yep. Good. How does SignalR work? SignalR needs a server, a so-called hub, and then many clients can connect to this hub and spoke architecture. You know hub and spoke? If you take a look, the idea yes. The idea is something like this. I can use that one. This is the hub. We will create it in C#, and then we have many spokes, and out there we have the TypeScript and JavaScript clients which connect to this hub. And the hub can then receive a message from here and send a message to here. Okay, that's the idea, the conceptual idea of a SignalR hub. Good. So let's create a SignalR hub. I will do that in C#. We could do that in JavaScript. We can do that in other languages. If you want to know more, then you should go to the ASP.NET Core documentation. There is a separate chapter here which says real-time apps. You see it here. And if you want to learn how to build a hub with the language of your choice, go to Server Concepts. You can read it here. And here in the tutorials, you can, nope. Here. For the clients, they have separated it in languages. You see, .NET client, Java client, JavaScript client. The hub currently is just using C#. But that's not a problem, because in a few minutes I will show you how you can implement it without any C# involved. But give me a second. Currently, it's C#. So let's create a new project. We don't need to. We still have our project open. Do you have the project from the previous exercise open? If you have, then you can continue in this solution. If you haven't, because you decided not to do the gRPC sample, but you want to join in now, just create a new solution. Whatever you do, please add a new project. And in this project, we generate an ASP.NET Core web application. Let's call it SignalR Server. That should give you an empty SignalR Server project. This is how it looks like. Good. Let's go to Startup. And here we can now enable SignalR. The important message behind the lines here is, again, we have a single programming model, ASP.NET Core, and then we can add REST APIs, we can add gRPC APIs, and we can add SignalR in a single project. Everything works the same. Dependency injection, logging, all the stuff that you have learned, everything works together. And in this case, we just need to enable SignalR. How do we do that? It's a two-liner. We say services.add SignalR. That's adding SignalR to dependency injection. And then, once you have added the add SignalR, we can register a so-called hub. Endpoints dot map, and if you take a close look, then you should find map hub. This is the hub and spoke architecture that I told you about. So let's do a map hub. It needs a type parameter, and let's call this guy drawing hub, and let's make it available under hub. This is just the URL under which the WebSocket connection will be made available. And this is an arbitrary class name. You can call it whatever you want. We have to create this class. This is the class that we are going to develop together. So let's add this class. Right-click on the project, add class, drawing hub. It has to derive from hub. And we're done. I added a class, drawing hub. Let me quickly put that to the side so you see both things. Here, this map hub drawing hub refers to this class, and it derives from hub. This comes from the SignalR package. Really not complicated. Everything would be so nice if it wasn't about security. I'm running the WebSockets server and my client on 2 different ports. You will probably do the same. So we are running WebSockets on localhost, I don't know, 5001 or something like this, and we will run our sample app on the localhost 8080 or something. So that means we have to deal with this beautiful guy named Course. Course is a security protocol that makes sure that a web page can only load data from where it came from. If a website, if JavaScript wants to load data from a different domain and the port difference is enough, then you need to explicitly enable that. That has nothing to do with WebSockets. That has nothing to do with SignalR. That has just to do with the fact that we have 2 different web servers talking to each other. Okay? If you're not familiar with Course, yes, I know we have to write 4 lines of code now, but they have nothing to do with SignalR or WebSockets. That's important for me. So let's add Course. Services.add Course. Who has ever struggled with Course? I am in, I feel your pain. In 1 day a week, I'm teaching at an Austrian college for computer science. And believe me, the beginners, when they see Course for the first time, they struggle with it all the time. It's really not nice. So what we need to do is we need to enable Course for SignalR, and we do that as follows. app.useCourse, and then we have to say a builder, and then we have to say, let's see, I have it in my GitHub repository, but it's only 1 line of code. Builder with origins, and we allow HTTP localhost 8081. Please add 8080 here if you run it on 8080, okay? So the port under which it runs on your machine, and then let's say allow any header, allow any method, super secure, allow credentials. So in production, you should maybe consider either running both things, WebSockets and the web server on the same host, or maybe thinking about which header you want or which methods you want or whatever. But this is now allow everything coming from localhost 8081. Good. Ready to go? I think we are. So let's implement the drawing hub. The first thing we are going to do is we are going to override a lifecycle method. There is a lifecycle method which says onConnected. It will be called whenever a new client connects to our hub. Okay? So we have a single hub, but every client that connects goes through this onConnected async method. So let's do that. Override onConnected async. If we want, we could write something to the log, but I hope you believe me that we can now do something meaningful. Here is where SignalR differs from WebSockets. I can immediately say clients. That will give me a list of all connected clients, and then I see something which is very beautiful. I hope you can you still read it? Yes. Clients.all. With this, I can broadcast immediately a message to everybody who is connected to my hub. Clients.caller. I can immediately start a discussion with the one that just connected to my hub. Clients.others means I'm talking to everybody except the caller. Imagine you're writing a chat. You want to notify everybody that a new client has just joined, so you would probably talk to clients.others. But be careful. These clients are just the clients that are connected to your WebSockets, to your SignalR server. If you have a farm of SignalR servers, then every farm server will have its own set of clients. So if you have a farm of, let's say, 3 SignalR servers, and you would like to talk to a specific client, then you have to make the servers talk to each other so that one server can say, who knows client XYZ? Then somebody can say, yeah, I know client XYZ, so please send him this message. You could use gRPC, or you could use some kind of messaging infrastructure to have a kind of communication patterns behind the scenes. Get the idea? Or you could use, I don't know, some RabbitMQ or maybe some, I forgot one platform. I don't care. You have a question.
Are there any best practices about the numbers of clients one server?
It's automatic. Numbers of clients in terms of capacity.
Yeah,
It completely depends on the work that you do.
So thousands is in principle possible as long as
absolutely, thousands for a single server are absolutely no problem in theory. A few hundred K of memory per client. It's primarily limited by the memory. So put a lot of memory into your server, it will not be a problem of CPU. However, it really depends. If you have only 5 clients and every of these 5 clients wants to do Bitcoin mining via SignalR, then you will probably not be able to scale to thousands of clients. But if you just have clients waiting for some notification messages, a few of them per minute, you can probably handle thousands of connections. And we'll talk about the solution for scaling in a little while. Good. So in my case, I would like to do the following protocol. Let me draw something quickly here. This is my server. This is my client. And I have multiple clients here. So if a client joins, connects to the server, I would like to pick a random color and send it immediately the color back and says, if you draw something, your color is red, green, blue, whatever, in order to be able to distinguish between the different draws on my whiteboard. You get that, what I mean? So I thought of this use case because it is a nice thing, so I can demonstrate to you how I can immediately, when a client connects, send something back to the caller, the color. You know what I mean? So we will do that as follows. We'll just say, give me a random number generator. New random. This is a random number generator in C#. Then we can build a color. And then color in HTML looks like this. RGB, like red, green, blue. And then we have to specify 3 color values. Well, that's simple. Random dot next between 0 and 255. 256 because it's excluding the upper boundary. that will give me, that here, will give me a color value between 0 and 255. So let's add 3 of them. That's it. That will give me RGB, value, comma, value, comma, value. Random color. Good? And then I can send the caller immediately a message by just saying clients.caller.send async method name, let's say setColor. That's an arbitrary string. We are talking to JavaScript, and JavaScript doesn't have types, so we cannot use a type here. We have to use a magic string. And let's send it an arbitrary color. This is what we had, color. I waited, because it's an async method. We have talked about that before, and voila, this is how we can talk to the client. If a client connects, immediately send it back a color. Got it? Yeah? We can also store the color. We can say here, context.items color equals color. What is that? What is this item stuff here? This is a key value collection that is associated with the current connection. So whenever I get a message from this connection, I can look into this items collection to find some properties that I would like to store here. Could be the username or the nickname in a chat, could be the customer number in some kind of support system that you are building. Any kind of key value pair can now here be stored, and context always refers to the current connection. Got it? To the spoke that we are currently on. Okay? Good? Nice. Now let's see if this works. Try to compile it. Should work nice. Good. Works on my side. And then you go to the starter code in the web browser, in Visual Studio Code, and please open our index.ts. Here we will add only a few lines of code. The first thing that we need to do is we need to install the SignalR JavaScript SDK. And that is done as follows. You just say npm install at ASP.NET/SignalR. The nice thing is that what you can take away from here, it is supported to write code in TypeScript in a type-safe manner. You don't need to write JavaScript. You can, if you prefer JavaScript over TypeScript, but most of you come from a Java world, so you like typings, right? I like typings, I like TypeScript, and therefore I don't like JavaScript so much. So JavaScript is a great language as an intermediate language, but I don't want to write code in it. I also don't write code in MSIL, but yep, that's just me. So install it, that's all we need to do. Then we have the SignalR protocol for JavaScript. It only takes a few moments. Good. And in JavaScript, or better TypeScript, you can import something with a statement like that. You just say import it from ASP.NET SignalR. And the thing that we need here is let's import everything. Star as SignalR, something like this. It just imports SignalR into our application. Let's use an uppercase R because it's kind of, yeah. That's how SignalR is written. Now let's try to connect to our server. How do we do that? We just say const connection equals to SignalR dot, and then we can use the hub connection builder, give it the URL, sorry, new hub connection builder, of course. give it the URL with hub URL. No, with URL. I think I specified HTTP localhost. I think we can even, it now depends. If you are on a Mac and you are running it without encryption, then you have to specify HTTP localhost. If you run it on Windows and you can use for ASP.NET SSL, then you can specify HTTPS. It depends on where you are running, okay? This hub here, this one, refers to, in C#, this hub. So you can have multiple SignalR hubs in a single application. It depends. Maybe you have a chat and you have a drawing whiteboard and you have different applications. You can host multiple of these endpoints in a single server. And at the end, we just call .build and we are nearly done. It's really only a few lines of code. Good? Now we can react on messages. We can just say connection.on, it wants to have a method name. Where do I get the method name from? Here. Set color. Set color. Whenever we receive a set color message, we want to call a handling function. And the parameter of this handling function is, guess what? The color that the server senses, right? And the nice thing is, Visual Studio or .NET will care for all the parameter marshalling. You can send complex business objects here. You don't need to care about JSON serialization and deserialization. You can switch from a text-based protocol to a binary protocol that is very, very efficient. You don't need to care about anything. So in this example, we see a bunch of interesting things. First, client management. Second, calling methods. WebSockets cannot do that. It can just send messages. And third, marshalling parameters. All these things are handled behind the scenes. You don't need to do anything. And that's the beauty of the SignalR protocol. So let's go here. This will be the color. And all we need to do is we say canvas.drawing color. So drawing color equals to color. That's all. We are now calling a method in JavaScript from our server, which might run in the cloud. Let's give it a try. Let's run our, oops, sorry. We have to change the startup project, otherwise it will not happen. I now started the wrong project. So right-click on the SignalR server, set the startup project. And go for it. By the way, for those of you who are not that familiar with ASP.NET, here you have 3 options how you can run an ASP.NET app. You can run it behind IIS, Internet Information Server, not my most favorited version. You can run it as a console app, this is the second one, or you can immediately, if you have Azure and Kubernetes cluster there, you can immediately run it within a Kubernetes cluster in the cloud so that you can F5 debugging and everything on your local machine, although your application is running in Kubernetes in the cloud. But we don't have Kubernetes here, so my favorite option is this one. That will spin up our SignalR server. And if I'm lucky, it should tell me that it runs on, localhost 5001. See it here? This is the URL that I specified in my JavaScript code. Good. So let's go here. Let's go network. Let's go F5. Interesting. You see? This is already the result of us using SignalR. It used a WebSocket connection. We can take a look, click on that WebSocket connection, and you will see that we already got a bunch of messages sent around. Now, if we draw, we didn't get a color yet, and I'm not exactly sure why. Let me quickly check. Let me quickly set a breakpoint here, just to make sure, and run it again. For whatever reason, what did I do wrong? So we have our SignalR server here. Okay, let's restart it. Maybe I have a caching topic. Let's see. So, nope. Let me quickly check what I did here. I registered the drawing hub. It's running on the hub. Doesn't get any error.
There is another thing in Chrome after WebSocket that shows the color. Refresh maybe.
Ah, this is the wrong WebSocket stuff. I now see this is the wrong WebSocket stuff. Yes, absolutely. This is the WebSocket that is caring for auto-refreshing the website. That's the problem here. So I probably need to stop my Webpack dev server and run it again. Let's see if that works better. No, I know what I missed. I just saw it. I'm sorry, but this is live coding. I react on the connection. I build the connection, but I never actually initiate the connection. That's my fault. So what we need to call is connection start, and we have to await this guy. Yeah, that was my mistake. Sorry. I never started the WebSocket connection, so it cannot work. Good. I mean, not good, but good that we found it.
Oh, yeah.
Now we should, if I press F5, we should hit a breakpoint here. You see, this breakpoint was now hit because we initiated a WebSocket connection between our server and our client. So let's run this through, and that should give us here a different color, you see? And if I refresh it, we should get a new color. And if I refresh it, we should get a new color. This is exactly what we have. And we can see that this really happens if we go to sources, webpack.source index.ts. We can hit a breakpoint here or set a breakpoint here, reload it, and then boom, we stop here and we receive the random color, as you can see it here, from the server. So this is the server calling a JavaScript method on the client.
So you can open several browser instances?
Absolutely, but we will not talk to each other. That is the last 2 or 3 lines of code that we have to add. Then we are done with this sample. Yes, of course, this is our goal, that we draw, that we can draw in multiple browser sessions and then see what's going on behind the scenes. Let's add that. What do we have to do? First, I've prepared something. I have prepared in my canvas here, I've prepared a callback method that will be called whenever somebody has drawn a line on our canvas. Okay? So the canvas tells us, hey, the user has just drawn something with the mouse. And then we need a message from in the other direction. We need to send something from the client to the server. This is the second direction of SignalR. Okay? So let's do that. That's pretty simple. We can just access the connection. This is the WebSocket connection that we see up here. We can say connection.invoke. Now we are calling a C# method on the server from the JavaScript client over the network. Give it a name. Let's call it draw. And give it the coordinates. The user just has drawn a line from the previous point to the next point. These are just points on the canvas. Okay? So when the user draws around every mouse move will initiate a call to the server. Good? Now, how can we intercept this method on the C# client? Server, not client. Extremely simple. We just have to define a method with the same name as we referenced in JavaScript. In JavaScript, we called it draw. No, so we will do a public async task draw. We will get parameters. Now, what is this previous here? In my case, in TypeScript, I have defined an interface, TypeScript interface, iPoint. This is a complex business object. Let's say it this way. What is point? It is an X number and Y number. It's a complex JavaScript object. It can be as complex as you want. It can be your customer, your order, a chat message, whatever you want. Just a JavaScript object. So what we can now do in C#, and that's the nice thing, we can create a class for that. We can create a data transfer object class, a DTO class, and SignalR will do the marshalling between JavaScript and C#. So let's add a class, public class point, with a prop. If you don't know Visual Studio, it works like this: prop tap tap, float x, prop tap tap, float y. Get it? So now that we have this, we can immediately use this. Point previous. It doesn't matter, you could use int too. Point. Next. To make it very clear, the marshalling, turning the JavaScript object into a C# object, is done by SignalR. That's another very important thing why SignalR has a reason for being here. You have a question?
Yeah. It's about sending a lot of arguments from JavaScript, because in JavaScript you're not limited to a number of arguments for a function call. So can we handle it in C#?
Yes, you can. C# can handle a lot of arguments, but I would not recommend doing that. I would recommend, if you have more than, let's say, 5 or 6, a handful of arguments.
Dynamic, for example, number of arguments.
No, put it into a JavaScript object.
Yeah, I know that the solutions, it's a question about dynamic number of arguments for a C# function.
A dynamic number of arguments for a C# function. That's a very good question. I've never read about it. I can use some time in the break to Google that, but unfortunately I don't know I never had this business case yet, but now I understand what you mean. Yeah. Okay, so if we receive from a caller that somebody has drawn on this window, we need to broadcast this draw message to everybody else. And what did I tell you about this hub architecture? We can say clients dot, and now we use the others, not the caller. You get the idea? Dot send async. Well, that's simple. Let's say we send draw. Let's add the previous point. Let's add the next point. And then we need to send the color. No problem. Do we know the color of the caller? Yes, we do, because we have stored it in context.items. Got it? This is the reason why we saved some something in the state, in the server-side state. Looks good. Just await it. Done. By the way, for the purists in the room, in C#, it's no longer considered to be idiomatic C#. If you write something like this, if you have a single line function in C#, it's usual to write it as an expression-bodied member, but that's just C#.
It's case insensitive then? Because here you have it with a capital P.
Yes. SignalR automatically translates the beginning letter into the idiomatic form. So it assumes that JavaScript uses lowercase letters for function names and properties, and C# uses uppercase letters for function names and properties. And therefore, it automatically does this conversion. Yeah.
What if is the name of the function is 2 words, like draw something? And it's
Then the second one is left as an uppercase letter. It's Pascal casing.
okay.
Sorry, camel casing.
In
Camel casing,
JavaScript
right?
is camel.
Camel casing is the first is lowercase, right?
Yeah.
I always mix that. So it's camel casing.
So in JavaScript.
In JavaScript, it's camel case. In C#, it's Pascal case.
Okay.
And the translation between camel and Pascal is done automatically. Good? We are missing a last step here, a very last step, a single line that we have to write in our JavaScript, and then we should be able to do that because we need to handle the draw message. I'm a lazy programmer, so I copy the connection on set color, but this time I'm handling the draw message, and I know I get 3 parameters. I get the previous point, which is an I point. I get the next point, which is an I point, and I get the color, which is a string. This is how you write that in TypeScript. Again, SignalR will do the heavy lifting to translate the C# point into the JavaScript point. I can just do type-safe programming. And what do I do inside of here? Canvas.draw. It wants to have draw line, sorry. It wants to have a previous point, it wants to have a next point, and it wants to have a color. Done. That's it. And we're done. Curious how this looks like? You have the whole sample already implemented in my GitHub repository. For those of you who don't follow along or who want to copy because it's boring to write so much code, then copy it from there. Let's give it a try. Let's run the SignalR server. Good. Here we have the first browser window. Let's do it like that. Put it on the right-hand side. Let's open a second one with localhost 8081 and put that one on the other side of my screen. And if I draw here, it doesn't work. Let's see. Oh, we have a lot of errors. We have a lot of errors. Why? Oh, I think I just refreshed before the server was up. Yes, you see? Yoo-hoo! Works perfectly well, just exactly as I want to have it. You can try it on your own, it really works. So now I could start the third one and the fourth one, but I think you get the point.
Can you show us the TS out again?
Of course, absolutely. Here it is. I've chosen this example because it shows really in a few lines of code a lot of interesting aspects of SignalR. It really makes, I think it makes one understand why SignalR is there, why SignalR has a value compared to pure WebSockets. And now maybe you understand better what I meant with select the function to call, server and client, marshal the parameters, and do the protocol negotiation when we don't have WebSockets available. Because you can add a web API and SignalR in the same server-side solution, it's really simple, for instance, to build an application that does 90% of the work with RESTful web APIs. So the browser uses post, put, patch, delete to do the typical stuff. And through the same code base, we also offer a SignalR connection. So for instance, if something takes a little bit longer, generating a report, inputting some data, we can use the SignalR connection to have a duplex communication, let the server send something to the client to notify it, for instance, that some results are available. Get the idea? You don't need to throw everything away. You shouldn't. You can still use gRPC or HTTP-based web APIs, but SignalR is just a side channel through which the server can talk to the client. Good? Does anybody still need some time here to see that? Okay. We are perfectly on time because we need to talk a little bit about recent developments in the area of SignalR. Some things have changed in the last few months, let's put it like that. The first thing that I would like to point out, oops, that's the wrong one. That's the right one. The first thing that I would like to, oh my God. The German version of this documentation cannot be read. That's the first thing that I would like to point out. Unfortunately, I only have 1.5 hours, so I can't go into the details, but I would like to tell you that SignalR now supports streaming. That is new. The programming model is extremely similar to what you have seen from gRPC. So if you have a scenario where the servers generate some values and streams this value to the client, or where the client streams requests to the server, or bidirectional, exactly like gRPC, you can do that now. This is brand new. This is an extension of the SignalR protocol. It now supports server to client, client to server, and bidirectional streaming. I decided to drop that demo because the programming model is the same as in gRPC, and you can look it up if you want. Okay? So, you know it, it supports streaming. I decided to do something else and talk a little bit about the feature which exists in the Azure cloud. And don't worry, if you are not in the Azure cloud, but you are in AWS or you are in the Google cloud, this is a service where it even might make sense to consider it if it's your only Azure service. I don't know. Let me show you what I mean. There is an Azure SignalR service, this one. This Azure SignalR service. Now, why should you use this Azure SignalR service? Now, the first one, let me show you these two pictures. The first one is if you handle all your WebSocket connections in your app and let all the browsers connect to your app, then you have the problem of scaling out. Imagine you are building an app that has hundreds of thousands of active connections. Think of, I don't know, a mobile browser game, for instance, a casual game where you have hundreds of thousands of players. Each player doesn't generate a lot of load on your servers, but it's the sheer number of connections that are really a problem. This is where ASP.NET, where Azure SignalR helps. Azure SignalR is a multiplexer for SignalR connections. You know what I mean? So Azure SignalR, it's a serverless service. It does nothing. It's kind of a reverse proxy for SignalR, and it multiplexes many client connections into just a handful connections to your app. You know what I mean? So you will have 5 or so connections open, and you will receive all the data from hundreds of thousands of clients through these 5 connections. And let Microsoft worry about the scaling. It's serverless. You don't need to deploy a VM. You don't need to tell Azure how large your servers are. It's completely serverless. You pay by the number of connections. Good? However, this might sound great, but who builds casual games here with hundreds of thousands of clients in the browser? Anybody? Nobody? I don't. So when I heard first about this service, I said, okay, this is something for people that are none of my business. But then 2 things happened. First, there came a technology which is called Blazor. Ever heard of that? Well, I will not win a lot of fans here in this room because the whole idea of Blazor is to replace JavaScript with C# in the browser. So what Microsoft did is they created a C# version running on top of WebAssembly. So you can now run your C# application in the browser without a plugin. It's not Silverlight. Without a plugin, directly in the browser. That's the idea of Blazor. Blazor is super popular for companies who have a strong investment in C#. They don't want to learn JavaScript, they don't want to learn TypeScript, they want to use their existing business logic without a lot of investment, without rewriting that in TypeScript and JavaScript. And guess what? Blazor has two different modes of operation. You can run your C# inside the browser with WebAssembly, but you can also tell Blazor, for instance, if you have a rather small client that is not capable of running WebAssembly, Internet Explorer, somebody? Still a thing in banks and insurance companies and enterprises, is still a thing. If you have something like that, you still want to use Blazor, and guess what Blazor does? Blazor has two modes. Run on client side, but it can also run on the server side. It's exactly the same code. You write the code once, and with a single switch, you can say run the logic on the client or run the logic on the server. The whole document object model, virtual DOM thing, the diffing that you might know from Angular, React, or Vue, and so on, it's the same with Blazor, but then they run it on the server. They run the entire Vue model on the server and just say send so-called render trees, rendering informations to the browser client that it will update the DOM accordingly. That's not for public-facing, consumer-oriented web pages, forget that. But imagine you are in an enterprise where you have intranet applications for thousands of employees, for instance. That's a thing, because then you can control the server. You don't need to retrain your employees in .NET and in JavaScript and Angular and Vue. You can still use C#. And the protocol through which this goes is SignalR. And now it's getting interesting. Imagine you're in a bank, you're developing an application for, let's say, 10,000 employees, and they are all going to use the browser, but the whole business logic is running on the server, and in between you have SignalR. And suddenly you have the problem of scaling in a business application in a classical enterprise. And this is why Microsoft invested so much in the SignalR service in Azure, because then it really makes sense, not just for casual gaming. And the second reason why they invested in this stuff, and I have a sample for you, is you can build so-called serverless services. So essentially, what you can do is you can now, oops, I need to zoom in here. You can now push SignalR messages out to the browser client, mobile client, whatever, without implementing a SignalR server. What SignalR can, to the backend, it supports an HTTP-based API. And to the front end, it supports WebSockets or SignalR. So what you can do is you can say, give me an Azure SignalR service, and if you want to push something out, you just do an HTTP call. Want to have it in Java? No problem. You have now a possibility to talk WebSocket over SignalR without implementing SignalR. Because the SignalR implementation will be done here, and you send out notifications to specific clients, to one client, to all the clients, through this service via a RESTful web API. You get the idea? I have to demonstrate that. I brought a sample. It's in GitHub. I can show it to you, written in Go. Go doesn't have a SignalR server. I cannot implement a SignalR server in Go. Well, I could, but there is none. I would like to, but nobody pays me for that, so it doesn't work. But still, let's think about the following. Let's say we have, what do we have? We have a temperature server, and every few seconds I would like to send the updated temperature. The temperature sensor is read with this Go application, and this Go application would like to send it to a web page. Okay? So maybe this is an IoT scenario, smart home scenario. I have a website and I see the temperature of my house in real time. But the server, the IoT devices, runs Go. So no SignalR server. What I did for this workshop is I quickly set up here in Azure as Azure SignalR service. Where do we have it? API Conf 2019. It's just click, create, done. No virtual machine, completely serverless, nothing like this. This is the server, Azure SignalR. And this Azure SignalR has a name, API Conf 2019. And now from my Go application, whenever I would like to send out something via SignalR, I simply send an HTTP request to Azure, and Azure can talk to all the connected SignalR clients. So in JavaScript, I'm using SignalR, exactly as you have seen before. But on the back end, I can use anything. Java, Go, whatever can speak HTTP. Get the idea? Let's try that. What does this code do? It's a little bit of a small web server, and if you are interested in how Go works, come to my session tomorrow. I will talk about web APIs in Go a little bit. And the only thing that I do here is, I just will show it to you. So let's run this guy. Run. Good. It listens on port 8080. So let's go into my browser here. Let's go to network, and yes, that's fine. Clear everything and go to localhost 8080. Boom. Not very impressive. Every few seconds, I get a random value. Now imagine, this is our smart home. The Go application reads a sensor and it sends back data to the client via SignalR. So this is the temperature in our house. Well, hopefully not, because then we would have a problem, but you get the idea. Now let's take a look at what was happening behind the scenes. Well, the first thing that the SignalR client, JavaScript, did, it called an endpoint. I've called it chat, but I can call it anything. I just took it from another sample. It's called the negotiate endpoint. And this negotiate endpoint can tell the SignalR client in JavaScript, hey SignalR client, you would like to talk to me via WebSockets? I cannot talk WebSockets with you, but please go to API Conf 2019 service signalr.net. That's the Azure stuff. From there, you will receive messages. And these messages come from me. And by the way, when you go to this Azure SignalR service, please use this access token to prove that you are coming from me. You get the idea? I have a web server. The client says, I would like to talk WebSocket with you. And this web server says, I'm sorry, I'm written in Go, I can't. But please go there. This is the access token. Listen to them. And whenever you get something from them, it's from me. You can display it. You can trust it. Get the idea? Next one is a negotiate with Azure. You see? Now it talks to the Azure SignalR service, and at the end of the day, I get a WebSocket connection, see that one, with Azure, not with my Go application. Click on it, and if we go to messages, we will see that here we have some messages going through. You see a measurement of our temperature server, a bunch of arguments. We don't care about it. That's the SignalR protocol. That's an implementation detail. But we see the messages are really going through exactly like we want to have it. And what does our Go application do? Well, it doesn't have any SignalR stuff. At the end of the day, it does a little bit of JWT token magic. It creates a JSON web token, and then it uses a plain old HTTP post to a URL that it got from Azure, and with this HTTP post, I can reach all my clients. And you have a nice REST API with which you can create groups of named clients, so you can directly send something to a group of clients, to specific clients, to multiple clients that you specify, so you have the full power of the SignalR protocol without implementing SignalR. And this is super relevant for companies and for scenarios where you can't or you don't want to have a SignalR hub in your application, but you still would like to have, with a few lines of code, a bidirectional communication with your browser clients. You get the idea? And this is relevant for all the programming languages out there for which we don't have a SignalR server.
For which language do we have?
Pardon?
For
So which language do we have?
I showed it to you before, .NET, Java, and JavaScript, but you were talking about the server, right?
Yeah.
Very good question. I only know the .NET one. Let me quickly look. Java client. There seems to be a Java SDK from different people. To be honest, I don't even want to try and answer because I would have to take a look at various open source projects and my Java skills are too worse to really analyze whether the implementation makes sense. From Microsoft, you get the server in C# and multiple clients. But with Azure SignalR, you can do it in any language. That's the idea. Okay? Of course, this is also done by Microsoft internally when they build things like their Azure portal and so on, and they want to have a duplex communication with the user. And then they build a regular web app, single-page app with a RESTful web API, and use SignalR as a back channel to send notifications if long-running stuff is finished, for instance. Question?
In your example, you
Yes.
used the Azure connection to broadcast.
Yes.
What about the other direction? Do you then implement basically an endpoint?
No,
on both sides?
you use classical HTTP-based REST API. So if the client wants to send something to the server, it uses our HTTP post, get, put, patch, whatever.
So it won't send something to Azure
No.
and Azure then
No,
translates this
it will
directly
not.
then?
No, it will not. Not currently. Not saying that this will not come anytime in the future. I don't know. Nothing to announce here. But currently, no. It's sending out notifications to clients. Good? Good. And with that, we really landed on the spot. It's 3:02 p.m., so time management is okay. We now have a coffee break, and in half an hour at 3:30 p.m., we will again switch gears and start a new chapter, the third chapter that I promised you in the morning in the abstract. We are going to talk about OData, do a little bit of comparison with GraphQL, and again I will show you some code samples with OData. I would like to apologize early. It will probably not be possible to follow along these examples. They are already implemented and I will do more code walkthrough than coding because building these samples is a little bit more work and will probably not be able to make it. So I hope that's okay for you, but you will definitely all get the idea of how code looks like that implements OData. Good. Thank you and see you in half an hour. Enjoy the break.